Hey everybody, thanks for joining us again. In this video, we're continuing to build on our AI anime. This time we're showing how you can use text-to-speech models to generate custom voices based on just a tiny bit of audio. In the previous video, which if you missed you can watch by clicking here, we demonstrated how you can use watsonx.ai to generate dynamic, interactive anime scripts. We're taking the next step by bringing this alive using an AI to generate expressive voices for these characters. The challenge lies in getting the AI to accurately model the characteristics of anime-inspired dialogue. This includes correctly capturing the intonation, the speech, rhythm, and tone, all while giving it an emotional range. Anime has a unique dialogue style. They typically contain exaggerations, have internal monologues, or cultural references.
But will this model be able to smoothly transition between different characters in different environments? Or will the voices be distinct enough? Or could we even get a character's voice like Eren from Attack on Titan? Let's find out. Right, so I'm going to break this video down into 4 simple steps. Step 1 is what is text-to-speech. Step 2 is how we go about choosing our model. For this particular one, we are using the F5 TTS. More can be found through the link here. Step 3 is how we go about adding emotions to the voices, and step 4 is bringing that all together to generate the anime voices. So without further ado, let's get into the video.
So the model we're going to use today is F5 TTS. If you're interested in learning more about this model, we'll include the link to the original paper in the description. So F5 TTS is a diffusion model, which are those powerful AI models behind some of the most mind-blowing generative tools like DALL-E. This sounds complex, but don't worry, we'll break it down for you in a super simple way. So imagine we have this adorable picture of a cat. Diffusion models work by taking an image like this and gradually adding random noise step by step until it looks like complete chaos. Think of it like tuning an old TV to a static channel. Eventually, all you're left with is pure noise.
This process is called the forward diffusion process, where the model progressively corrupts an image with Gaussian noise over multiple steps. But here's where things get really interesting. Diffusion models don't mess things up, they learn the reverse process. This is called the reverse diffusion process. Starting from pure noise, the model gradually removes the randomness step by step until it reconstructs the original image, or even generates something entirely new.
At the core of the diffusion models is the idea of a Markov chain, which is basically a multi-step process where each step only depends on the one before it. So if we're at step 3, we only need to know about step 2 and nothing else. So during training, the model is shown an image at different points in the noise process, like how many noise steps have been added. It then learns to predict the noise that was added in the previous step, and once it figures that out, it can then subtract the noise, getting one step closer to a clear image. When you want to generate new data, the process works in complete reverse. You start with pure noise and denoise it step by step, just like rewinding the original corruption process.
And here's the best part, diffusion models can be conditioned, meaning they take an extra input like text description or a class label. This lets us guide the generation process to get exactly what we want, like asking an AI to generate an image of a golden retriever wearing sunglasses. This ability makes diffusion models super powerful for applications like art generation, super resolution, and even noise generation, where recovering fine details is crucial. So the next time you see an AI-generated cat or a breathtaking piece of AI art, remember, it all started as nothing but noise.
All right, so we've got the F5 GitHub here, which has a nice sort of app to do this text-to-speech for us. And we'll go over the short installation instructions and also just show you a little bit about what F5 is. So we've already spoken about the fact that it's a diffusion model. It's also a flow-based model. So Imran, I don't know if you want to go into that at all. We may not have time.
Yeah, so it is a diffusion transformer-based model that was released fairly recently. I think it's about 7-8 months ago, and it also uses flow matching, which has some relation to optimal transport. For all the details, the link will be here, but we'll go through the installation.
Yeah, we'll include the link to the GitHub and the paper in the description. And so we're going to go over the installation. We've already got most of it installed. So we'll skip the sort of conduct creating the environment, cloning the repo, and the torch install. A small side point, and this is true for us, is that we don't actually have a GPU on our machine here. So if you don't have a GPU, there's a couple of things that you need to change about these installation instructions to make it work. And what you need to do is you need to remove this plus CU118 from this command here. So if you remove those 2 bits, it will install the torch without relying on a CUDA GPU. From there, you then can just follow the same sort of, you create your virtual environment, install the dependencies, and then it is really as simple as just running this singular command. Now, there's one more command you need to run, and I will show you on my terminal here, which has already got the dependencies ready in its virtual environment. And that is, we just need to run this export PyTorch enable MPS fallback equals 1, we're just setting an environment variable that tells PyTorch that if you can't find a GPU to fall back on the native CPU. So you run that, and then you run this command here, and it will spin up a server for you to go to, and it will give you the link as well very nicely. So just give it a second. If you're running this for the first time, it's going to take a bit of time as it downloads the necessary models it needs. So give it a second. You can see that this is just doing a bit of loading here. And so Imran, I think this is probably a good time then to talk a little bit about our expectations here and what we're hoping for and what sort of are the typical pitfalls of a text-to-speech model.
Yeah, that's a really great question, Brendan. So I want to preface this by saying that we are not fine-tuning anything here. We're literally taking the model as it is out the box. So that's got to draw our expectations down a little bit. But at the same time, things I'm really interested in focusing on is capturing distinct voices. But not only that is, can we add emotions to voices? Because that's one of the unique capabilities of this particular model. So I'm super interested to see out of the box what it can do, see how it works with our scenario.
I think it's great. So what we've done is all consenting individuals here. We've got a few of our friends who very kindly sent us, just 10-second recordings of their voice. The way this works is to express the different emotions. You have to have different recordings for different emotions. So what we're doing is we're going to use you can use the basic TTS if you just want to do one voice line at a time. But we're going to actually use the multi-speech. And that's just a little bit faster if you want to do multiple voices. And so the way this works is you just drop an audio clip in here. And so here are our regular ones. Brendan will be me, and I will make myself the protagonist of this. Thank you very much. So I'm going to be Hiroshi Regular, right? Now, a couple of notes is that you can provide it with reference text, and that's great, and it will help aid the model. But if you don't want to do that, and you're really lazy like we are, what we'll actually do is call OpenAI's Whisper model, which is a speech-to-text model that will do the transcription for this. So we're going to not provide any reference text, and it's only about 10 seconds of audio that's required to do this, which is a little scary, really, but it's really cool.
Awesome.
So I'll just play this just to show what I mean. This is a test. I want to see if I can properly synthesize my voice and create great voice acting. So you can see it's just sort of me speaking in quite a muted, sort of almost robotic tone. So that's just something to be aware of. I'm certainly not an actor. I think that's something that both you and I struggled with here, is that actually there's still some level of you have to provide the emotion here.
Absolutely. And I was about to say, you sound really enthusiastic here. So we're so we're definitely throwing the model a curveball, right? So we're not really giving any emotions here at all. So we're trying to keep as monotone, raw voices. We've not edited these voice scripts at all these voice recordings. We're just trying to give it the sort of the worst possible scenario and see the outcomes. But just going back to Brendan's point about not providing reference text. So am I correct in saying, Brendan, that we're actually using speech to text and then text to speech? Is that right?
Yeah, we're in a loop. That's how it sometimes goes with AI. You have AI validating AI.
Absolutely. Fantastic. So as you can see, what Brendan's doing here is we're just uploading different voice snippets for the different characters that we have here, but also we are labeling them by the type of voices. So for example, we have regular voices, but we also have voice snippets of different emotions, so such as enthusiastic or quiet, and hopefully, fingers crossed, the model will be able to pick up on those.
Yeah, so just to say, we're only going to take a short snippet because we don't have time in this video to go through the entire script, but we're going to take a short snippet from our previous script, which I will copy in here. I've actually hand transcribed this all through.
Yeah, Brendan has spent blood and tears of putting this all together. So please, everybody, like and subscribe. Really appreciate that.
So let's take this. I'm just going to add the label here. Ooh. How does this work? Sorry, give me a second. Oh, there we go. It's down here. I can see it.
So the cool thing about this is that we give all the text as a single particular file. And that's really useful for our anime script, which you saw in video 1, where we have the constant back and forth between different characters. So this provides a very cohesive way to just simply drag and drop some of those scripts and put them here. Whereas in other scenarios, you would have to do it voice by voice basis, and then you would have to use specific entries for our script based on certain people who are talking at that time. So this was a nice blend of actually just drag and drop and see how it works.
Yep. And I'm very curious to see the results, but you know, we have to be slightly muted. I'm not sure if this technology has quite surpassed the voice actors of this generation yet. So we'll see how this goes.
Absolutely.
I think if you are a voice actor, you don't have to be worried about your job being replaced soon.
So are you saying that we're not going to be able to start our anime studio then? Is that right? Our AI anime
need to
studio?
hire a few individuals if we're planning on doing this, Imran.
Right, absolutely. No, sounds great.
Okay, I think this is everything we need. So
Cool.
I'm just going to click the generate multi-speech style. This will take a few seconds to run, so we'll probably check back with you once it's completed and then see how it sounds. So welcome back, everyone. We've now actually ran the thing. And a couple of things I wanted to show before we play the clip and have our little moment of truth is you can see that we've got the transcriptions that have now been automatically put in here from Whisper. And they're actually very accurate. So I can see that, like, looking at this, that got the transcription perfect. And on that note, Imran, are you ready?
Oh, I'm so ready. Let's do it.
Okay, I'm a little nervous, but
I am
3,
very nervous.
2, 1.
Mr. Nakamura, a word, please. Your application mentioned unusual sightings. Have you experienced anything since coming here?
Yes, actually. Just today, twice. They were pretty vivid.
Keep track of them. Sometimes our surroundings trigger latent abilities. If things become too intense, come and talk to me immediately.
Wow. So that's super interesting, actually, because there's definitely some good and some bad here, right? So, again, I'm going to reiterate, voice actors, you don't have anything to worry about right now. So what were the things that, like, kind of first popped out to you here? Because I definitely have some thoughts.
Yeah, so it's really interesting that it captured the emotion and cadence really well of Professor Ono. I felt that when it transitioned to Hiroshi, so your voice there, Brendan, it made it almost appear like you were speaking fast. So that we have to probably work on that transition. But overall, I think the tone was really quite accurate. What did you think?
Yeah, no, I thought the same thing. I mean, the first thing that stood out to me is how accurately it actually mimicked the voices of me and our friend who generously lent us her voice for this. So it got the voices bang on the money, but the cadence for me was definitely too fast. And I wonder how much that has to do with the voice clip, and if I had recorded it differently or maybe even acted a little bit better in my voice clip, would it have come out better? We don't have time to just try loads and loads of voice clips, so we'll leave it at that. But, I think that was really interesting. I also noticed that what I thought is that for Professor Ono, I thought the quiet and concerned voice went really well, but the regular voice was still a little bit rough around the edges in my mind. So I do think a lot comes down to the voice clip that you give it in terms of how naturally do you speak. Maybe there needs to be some variety in the words you say. It's a really sort of big topic in terms of how it analyzes these things.
I love that, Brendan. So essentially the conclusion is we could just blame it on our friend for not having a great voice. Is that right?
Yeah, the acting skills were not up to snuff.
Sounds great.
Great, but overall, I would say this is really, really cool. I mean, we're definitely, progressing along with our completely AI anime. So that's the next step in the chain. Is it going to be better than Attack on Titan? Well, the script might be. Well,
will it? Will it?
Maybe not. But the script is pretty good. I think that the LLM did a really great job.
Absolutely.
Now, I think the voice acting, maybe it'll be a slight pain point, but it certainly won't ruin it for me.
Yeah, no, I completely agree and echo a lot of what you're saying. I was actually quite pleasantly surprised considering, we've given it the worst possible scenario, no fine tuning, straight out the box, maximum of 10-second snippets. I mean, we could do probably a lot better, but as a first step, this is moving in the right direction. But to add modalities is key to get our anime up and running.
And we've got plenty of more modalities to explore, so you'll have to stay tuned for the next one to see what comes up.